Okay, so we're going to have a look at this question here, and it's asking you to create a logic diagram and a truth table for the following Boolean statement. So we see here we have an AND with a line over it, which makes this a NAND. So it's an AND with an inverter, NAND gate. And here we have an exclusive OR. So the NAND and the exclusive OR are being joined together then by this OR gate here. What we're going to try and do is build this, then do the algebra bit here, and then test to see if this actually works. And so it's kind of a feedback system here on the logic circuit. So if we jump into the free simulator that we have, that we can mess around with, we have an input and an output. We want another input because we want to add B. So we have A and B. And then if we have a look here, we are starting with a NAND. So let's add a NAND in there. So the NAND is here. Move these over a little bit to give us some space. And then we have an exclusive OR. So we have an exclusive OR, which is here. Add that. And then these are being joined together by an OR. So let's add the OR. And then that goes to our output. So let's add this here when A is on, and then when B here. And then we'll join these into our OR gate, and from here to our output. So we're going to test that circuit now in a second, but let's do the algebra bit first. So we have an AND with an inverter, which is an AND. So normally an AND you multiply and then you invert it. So we have 0 times 0 is usually 0, but in this case it's 1. 0 times 1 is usually 0. In this case it's 1. 1 times 0 is 0, is 1. And 1 times 1 is usually 1. In this case it's 0. So that's our NAND. Then our exclusive OR is only on when one of these two states are on. The other thing way to think about it is it's subtracting them. So this 1 minus 0 is 1, 1 minus 0 is 1, and this will give us 0 here. And then to get this answer here, we have to add these two answers here. We're going to add these ones. So we have 1 and 0 gives us 1, 1 and 1 gives us 1, 1 and 1 gives us 1, and 0 plus 0 gives us 0. So if we were now going back, and I'm just going to highlight these because these are the two that we're testing, see if our circuit diagram is working. So if we bring that back up here, and we see what happens when the two of them are off, 0 and 0 is giving us a 1. So that's working. Then when we have 0 here and 1 here, it's giving us a 1. That's correct. When we have 1 here and 0 here, that's giving us a 1. And then when they're both off, that's giving us a 0 here. So you can see the logic diagram circuit is validating the truth table here.